Sea Education Association has been introducing marine-minded students to oceanography and sail training for 40 years. Covering over 1 million miles of ocean, 7,000 undergraduates, high school students, and teachers have participated in science programs in the Atlantic and Pacific, bringing back tales of adventure on board the Westward, the Corwith Kramer, and the Robert C. Seamans. These individuals become ambassadors of knowledge about our oceans. The 2012 Plastics at Sea expedition continues the legacy of scientific research SEA has developed.
From the captain's perspective, the voyage was a great success. We brought together a group of people from all different backgrounds, from all over the country. They joined the ship 37 days ago, came together as a crew. We've sailed the ship over 3,000 miles from San Diego through the North Pacific Gyre and on to Honolulu, Hawaii.
Volunteers were drawn from a diverse pool of alumni. Sharing the science deck with the SEA crew, graduate students, PhD candidates, and researchers conduct experiments and observations while underway. They will then return to their home institutions to analyze their findings and attempt to draw conclusions about plastic concentrations and their influence on biology and habitat.
My name's Zora McGinnis, and my project is to do visual surveys of macroplastics as they float by the boat.
Less than 2 centimeters is mini, and I have been seeing a lot of mini stuff because we go so slowly. I can see the little chips. I got my rangefinder, which will tell me the distance of any of the plastics I see floating out from me. I'm mapping our tracks for the hour-long transects. I'll record the start time, GPS coordinate, end time, condition, like the cloud cover, because that affects my ability to see things. I have to record size classes.
Part of my project is to look at plastics in fish stomachs.
The key to understanding what is happening out here in the gyre is first understanding what's happening at the microbial level. Each piece of plastic out here has a base layer of bacteria growing on it, called a biofilm, made up of countless numbers of microorganisms. Because these biofilms are thought to play a major role in the outcome of what happens to these plastics, I will be preserving plastic samples for genetic work and high-powered microscope work to examine the biofilms back in Woods Hole. Here on the ship, I will be collecting and analyzing plastic from fish guts, culturing bacteria, collecting seawater samples, and testing for bioluminescence in plastic pieces.
I'm researching microplastics, and those are plastics that are mostly invisible to the naked eye. That little filament that is now
The question mark?
the question mark in the center.
That's plastic?
That's plastic. They attract hydrophobic toxins like PCBs and DDT, and because microplastics are so small, they then have the potential to affect the organisms that comprise the very base of the ocean's food web.
My name is Kristen Mitchell, and I'm researching selenium in relation to plastics. Plastics have the potential to affect all sorts of biogeochemical cycles, and it just happens that selenium is my area of expertise. Selenium started out as a tracer for early life. Pretty much every form of life needs selenium to live. It can also be toxic, so it's a very fine line between having enough and having too much. What we found is that phytoplankton in the surface ocean is one of the main drivers of the marine selenium cycle. A few years ago, when Kara Lavender Law's paper came out in Science, I just thought it was so cool that they managed to use the large data set they had of plastics and do something meaningful with it.
So I'll be looking at different aspects of these macro debris chunks. My particular hand in this will be looking at species diversity. I want to look at how the size of the macro debris and the extent to which it's isolated from other debris that we find, how that affects the diversity of the organisms on board. And we're also going to be doing some sub-sampling of the surfaces of these macro debris and actually looking at the identities, specifics to species-level identities of some of these organisms to get a sense of potential species invasions and maybe range expansions.
Total from net tows, we collected 66,077 pieces. I feel like I can speak for every sailor on board that this was a life-changing expedition. That each and every one of us has a better respect for plastic and its uses in our daily lives.
I'm just really excited to be a part of this expedition. I think it's really exciting. A lot of us don't really know what to expect. I'm certainly one of those people. I'm hopeful we're going to find some interesting information and get a better sense on what the plastics are actually doing to the marine system.
Science can be so isolating, and in an environment like this, you can see that other people really do care and want to know more. It makes you remember why you started doing science to begin with.
I'll look back fondly on the moments on the quarterdeck with the crew playing their instruments, dolphins in the background, ship sailing downwind.
As the Hawaiian Islands rise up to meet us on the horizon, the sailors on this expedition ponder their return to homes, families, and jobs. What next? How will our plastics research aboard the Robert C. Seamans change our habits, our communities? How will the discoveries we made in the North Pacific Gyre matter in the context of our daily lives?
This was a very rigorous scientific program. We have not only photographs, but we've got videos, we've got personal testaments to things that happened on board, and we've got a lot of scientific data that's going to help us bring all of this information to the public. And that is one of the major goals of this research cruise, is to stop having all of this scientific data that typically just stays either on the bench or in a scientific notebook or in a primary literature paper, and get it out there. Get it out to everybody that we can reach in any capacity.
The day we sight land happens to correspond with the United States presidential election. It renews a sense of patriotism and also responsibility. It will be up to each individual to bring the science we carefully conducted on board to a practical end on shore. Thinking about how to manage plastic pollution in the Gyre is the first step for many, but this is a global issue. SEA will be at the forefront of this dialogue by creating and informing future scientific leaders, educators, advocates, environmentalists, and policymakers. We hope our work inspires everyone to participate in formulating solutions to plastics at sea.